I'm Chief Master Sergeant Jerry Lewis, the Chief of Enlisted Matters for General Timothy Green, the Director of Civil Engineers. I want to welcome you to Silver Flag and tell you how proud General Green and I are of you and the phenomenal work you do every day. Today I want to talk about the Airfield Damage Repair Modernization Program. ADR is one of the largest modernization efforts for the CE community in the last 20 years. In fact, it tops Chief of Staff General Mark Welsh's list of concerns facing the Air Force today. As you will learn, ADR is more than just modernization rapid runway repair, or RRR. It's a holistic approach to opening, maintaining, sustaining, and recovering airfield operating surfaces. Our senior leaders recognize airfield surfaces are a critical component of air power. Let's face it, without proper airfields, the Air Force's multi-million-dollar aircraft would just be static displays. The ADR program is multifaceted, but today we're going to concentrate on the largest component, airfield recovery after attack, and its 8 distinct capabilities. The first is a more efficient method of performing damage assessment. It's known as the Rapid Airfield Damage Assessment System, or RADAS. RADAS will utilize remote sensing and geographic information systems to assess the damage and select the minimum airfield operating surface within 30 minutes. This system is currently being developed, and we hope to start fielding in FY16. The second stage is the Multiple UXO Removal System, or MERS. It's a family of systems, and yes, the rumors are true. It will include a laser. MERS will be a mix of remotely piloted aircraft, ground robotics, as well as an MRAP with a turret-mounted laser. MERS will enable our EOD technicians to mitigate thousands of UXOs faster than using current clearance methods, which should allow crater repair operations to begin within 60 minutes. This system is also currently in development with hopes to field in FY16. The third stage, and the one you're all interested in, is damage repair. The cadre is going to take you on a deeper dive, so I won't steal their thunder. However, suffice it to say, we are fielding a capability that will enable you to repair 120 craters in just 6.5 hours. I know that seems like a daunting task, but you'll see it's doable. And in the end, you'll be burning fewer calories than when you were performing RRR. The remaining 5 stages are the legacy capabilities for FOD removal, emergency airfield lighting, mobile aircraft arresting system installation, minimum operating strip marking, and paint striping. While some of these are also being modernized, the modifications are mostly adjustments to tactics, techniques, and procedures to support the ADR process. Now I want to take a moment to answer 3 key questions about ADR. The first question is, why modernize? Primarily, it's in a response to the expected threat. Our existing capabilities were developed to respond to Cold War threats, repairing 12 large craters in 4 to 8 hours. The emerging threat requires the ability to repair up to 120 smaller craters in 6.5 hours. Secondly, we no longer posture single airframes at an installation, so our repairs must support fighter, airlift, and tanker aircraft. Added to this is the increased operations tempo. We no longer have the time to repair the repairs. The new materials and procedures are producing repairs capable of supporting over 3,000 passes before repairs may be necessary. How does this affect you? The new recovery procedures require civil engineers to be all in. Everyone will be involved in recovery activities. For example, a very large capability requires over 300 engineers. In the ideal world, the majority of them would be dirt boys, but we just don't have enough. The AFCEC ADR team has been working with your force development managers to identify your daily skills that are transferable to ADR, to include additional vehicle training. You may see structures troops operating the compact track loaders, performing saw cutting, or HVAC operating extendable boom forklifts. This will highlight the lean-forward, mission-oriented attitude we engineers exhibit every day. You will begin to see changes in the licensing and ADR requirements documented in Air Force Instruction 10-210, prime beef management, as well as tasks in your career field education and training plans. When will all this happen? AFCEC has begun purchasing equipment, materials, and vehicles this year. The Silver Flag sites will be fielded next year, as well as a few select WRM locations in AFCENT and PACAF. The entire fielding will take several more years, so there will be a mix of legacy and new capabilities across the Air Force. AFCEC has produced tactics, techniques, and procedures that will step you through all the various interim capability combinations in order to accomplish the legacy and new repairs. Now I know you're thinking, how can we train without the equipment, materials, and vehicles, especially at home station? We realize this is a bit premature. However, starting with the awareness training you're receiving now, you'll see some opportunities to start training at home, and like other low density items, we'll be developing computer-based training products as well. You'll also see the transitional skills I alluded to earlier, and hopefully by the time the capabilities are fielded, you'll be intimately familiar with processes and requirements. I know this transition will be difficult. We'll need to be afforded the training time and assets, and we must start practicing like we fight. So I challenge you to take home what you learn here and share it with your peers and leadership. Work with your wing personnel to modify local exercises to stress ADR-related activities. And lastly, be an advocate for change. Without a revitalized home station training program, ADR modernization and the ability to meet its stringent requirements are not attainable. Our AFCEC team has been studying this problem for 6 years and has conducted extensive research and testing. They have chartered us for success. As new technology and additional research provide improvements to the modernized ADR procedures, they will continue to reach out to you for validation and input. I again ask you to be patient and open-minded as we transition from the legacy RRR to the proven methods of modernized ADR. On behalf of General Green, I want to thank you for all you do every day around the world. Our work is a foundation the rest of the Air Force relies on to complete their missions. It's truly an honor to serve with you.
This is an introduction to airfield recovery after attack. Video footage and photos are from actual testing events. The threat to our airfields has changed since the Cold War, requiring changes in all aspects of airfield recovery after attack. Damage assessment teams are being replaced by remote sensing and geospatial information systems, better known as the Rapid Airfield Damage Assessment System, or RADAS. EOD personnel face the daunting task of mitigating thousands of UXO rather than hundreds. Instead of the traditional one-man, one-bomb approach, they will operate a family of systems known as the Multiple UXO Removal System, or MERS. Instead of 12 large craters, civil engineers must be prepared to repair 120 smaller craters, while maintaining legacy capability. Repairs must be capable of supporting thousands of passes for all airframes, airlift, fighter, and tanker. Supplemental to the repair efforts, lighting, marking, and aircraft arresting system requirements are also being studied to support the large minimum operating strip requirements. Modernized crater repair methods have been developed in order to address this major paradigm shift in airfield damage repair. The two major components of RADAS are the sensors and the data processing. The sensors can be mounted on fixed towers or within remotely piloted aircraft. The sensors will locate, measure, and classify all airfield damage in UXO. Then, Geospatial Expeditionary Planning Tool, or GeoXPT, will be used to analyze the data, select the minimum airfield operating surface, and manage the repair efforts. The system is in development and is expected to begin initial fielding in FY16. The next step is UXO mitigation. The Multiple UXO Removal System, or MERS concept, is a family of systems used to help locate and mitigate UXO threats. MERS is comprised of aerial and ground robotic vehicles, but is anchored by the recovery of airfield denied by ordnance or RADBO platform. RADBO is an MRAP with a Zeus 3 laser capable of neutralizing UXO in place much faster than the traditional one-man, one-bomb approach. The system is in development and is expected to begin initial fielding in FY16. The ADR repair team is made up of 7 specialized sub-crews. Each crew repeats their primary task on each repair sequentially through the repair zone, essentially working through the repair zone as a moving assembly line. The first crew's debris removal. The crew works their way through the repair zone, clearing each crater to allow the upheaval marking crew to begin crater profile measurements. When the upheaval marking crew moves from crater 1 to crater 2, pavement cutting begins on the first repair. Pavement breaking begins as soon as pavement cutting is complete on the first repair. After pavement breaking is complete on the first repair, excavation begins. Excavation is followed by backfill and finally capping. Notice how each crew moves through the repair zone performing their specialized task. Now, let's look more closely at each step of the repair process. After a section of the airfield has been cleared by EOD and the convoy has reached the repair zone, the repair process begins with a post-attack reconnaissance sweep, or PAR sweep. Once the PAR sweep has cleared the first crater, the debris removal team performs initial debris removal. The team completes initial debris removal on all craters in the repair zone before beginning to clear the open, undamaged areas. Debris is pushed to the predetermined side of the MOS for the FOD team to remove at a later time. The debris removal team also supports other teams during the repair process: pavement breaking, excavation, capping, and final cleanup. After initial debris removal is complete on the first crater, the upheaval marking team identifies upheaval and saw cut lines on all craters in the repair zone. Once upheaval marking is complete, the upheaval marking team members are reassigned to help with other ADR processes. After the upheaval marking team has completed the first crater, one of the two pavement cutting crews begins. As soon as upheaval and cut lines have been marked on the second crater, the second cutting crew begins. Spotters are provided to maintain the saw alignment and control the overcut lengths. The two cutting crews continue to leapfrog through the repair zone until all repairs are cut. After all repairs are cut, the compact track loaders may change tool attachments and assist other repair and reconstitution activities. Pavement breaking begins as soon as pavement cutting is complete on the first repair. The operator performing pavement breaking follows the saw crews. When all braking activities are complete, the operator is tasked to assist where needed until all repair activities and reconstitution are complete. Excavation is a critical step in the repair process. The spotter ensures repairs are not over-excavated and the perimeter faces are vertical, which is critical due to a limited amount of backfill material. When all excavation activities are complete, the crew is tasked to assist where needed until all repair activities and reconstitution are complete. Backfill begins immediately after excavation. The backfill process varies based upon the repair type, concrete or asphalt. If the repair receives asphalt, the flowable fill is wet placed with a volumetric mixer. The dry place method, known as slash and splash, is utilized for concrete caps. The flowable fill is a rapid setting, medium strength, cementitious material. It enables asphalt capping in 30 minutes and concrete capping in 15. Once cured, the material is still excavatable. The final step of the repair process is capping. The equipment, roles, and responsibilities of team members vary based upon the capping method. As mentioned previously, the repair will either be concrete or asphalt. Each of the two repair types are ready to receive aircraft traffic after 2 hours. The asphalt repair can be shortened to only 1 hour by water cooling the repair. While the concrete repairs are not able to receive aircraft traffic any sooner than 2 hours, they are ready to receive vehicle traffic in 1 hour. In addition to the primary crews already discussed, each repair team also includes a 3-person SPAL repair crew. Each repair team is supported by a dedicated warehouse operation. Warehouse operations do not require a building to work out of, they only require a semi-improved surface for material staging. When asphalt repairs are required, repair teams will be supported by batch plant teams. Each batch plant team will support up to 2 repair teams. The following sequence, filmed during an inclement weather demonstration, highlights how the various crews work through the repair zone. Debris removal. Upheaval marking. Observe how the repair crews sequentially progress through the repair zone. Pavement cutting, first crew. Pavement cutting, second crew. Pavement braking. Excavation. Backfill. Asphalt batching and warehouse operations occur simultaneously with repair operations. Capping. The warehouse continuously delivers, unloads, and pre-places repair materials at the repair zone until all required repair materials are delivered. Final cleanup. While the RADAS and MERS processes and equipment are currently being developed, the processes for performing airfield pavement repairs have been developed and equipment is being purchased and fielded. As soon as training sites have the equipment they need and the training plans are finalized, engineers will begin to train on the new processes for airfield recovery after attack. For more information on airfield damage repair, please contact the AFCEC Reachback Center.